We're going to start with our pipeline stuff. I'm just going to throw this guy up there. There we go. I can see everything that's going on. So what we're going to start with today is what I call pipelines. It's changed dramatically over the years, and it continues to change. But we're going to get into what are pipelines. It's kind of a broad category with a collection of things that we might actually use as we're developing our games. And it's the kind of stuff that people don't talk about a whole lot. People like to talk about game engines and rendering and game event loops and all sorts of artificial intelligence and stuff. But what they don't talk so much about that I'm going to get into in both classes to a certain extent is how do we build our games? How do we set ourselves up for success when we build our games? And that is, how do we make sure that when time is tight, when people are working long hours, when people are most likely to forget how to put something together, that we have a process in place that makes it easier for us to make our games. And there's a few broad areas where we're going to cover when we talk about this. So the things we're going to talk about involve an entire category of things called configuration management. And this idea is actually not one of those unique ideas to me or to VFS or to the game design companies in Vancouver. But if you dig around a little bit, and I'm going to have you dig around today, it's one of the areas that most companies that are very small typically overlook until it's too late. Most companies that are large have a very firm understanding of how important this topic is to delivering your final product. And once you have an idea and you want to make it important, there are some tools and techniques in our wheelhouse that we can get into. Now, configuration management is not exclusive to games. Almost every company out there of any significant size that is doing continual releases of their software have some sort of configuration management team or people or process to build their application and deploy it reliably. Often you'll hear it referred to as dev operations as opposed to live operations. And it's all about how do we build our project. And in the course, we're going to cover a bunch of the main areas that you need to deal with when we talk about configuration management. Two of the areas we're going to deal with are automation and tools. Automation is really about coming up with a way you can perform a task in the exact same way every single time you do it. For the most part, this involves some sort of scripting language, and it tends to be one of the things that is the most difficult to teach, because you kind of have to have a project and the project dictates what the tools need to do. So if you don't have a specific project to build, rules on what you're going to build are going to change dramatically. We're going to try and simulate that by trying to build up some automated tools to work with your final project. We're going to eventually tie into the cloud build systems that Git employs, which is one of the more modern ways of doing things, but it still doesn't cover the deployment aspect. And the whole idea of these automated scripts is to cover a multitude of things that we have to do. The first one is, how do we build our application? The second one is, where do we deploy it to? Where do we put it so that everybody can access it on a regular basis? Typically what you run into is, and especially in games, is a lot of the production management team that want to evaluate a game every day are not technical. and they do not have the ability to just open up some code in Visual Studio and push compile. So instead, they want a delivered version of the game placed on their desktop for them. Whether that's an auto download, or whether it's a disk that's generated, or whether it's a cloud link they have to press, it needs to be built for them. The other purpose behind doing this is, with developers, developers are, how do I best put this, optimistic. You always think you can do more than you actually can. You always think it will work more quickly than it actually does. And the net result of that is you're also the kind of people, usually by this point you figured out, that are in that, hey, this isn't working. I'll just, it's really close. I'll just, like, 5 more minutes. I'll just spend 5 more minutes and I'll just fix this, right? And what does that 5 minutes turn into? An hour and a half. And you get that fixed. And in fixing that, you find some other enhancement you can do. And you're like, but that's just like 10 more minutes. I've already been here an hour, so I might as well just spend that 10 minutes, right? Yeah. And then you look at the clock and you miss dinner. But it's okay, because you got something working and it looks really cool. But, with just a few more minutes, you could make it a little better. So you keep working and you keep working. And the next thing you know, it's like 9 o'clock at night. And you're like, wow, I haven't had dinner. I'm kind of hungry, right? So then you get some junk food. You get a sugar high. Can't go to bed now. So you might as well add a few more things, right? So you add a few more things, and that breaks a few more things. And so you got to fix those things. Next thing you know, it's midnight. And this cycle is so common amongst developers that it takes a lot of work for us to physically break ourselves of that habit, right? Now, the best way I've seen teams break this habit is by having their automatic system build their game in a very specific time of day, every day. And there's a couple different strategies for this, but essentially most developers will build their game every night, overnight. And they'll pick a time of day that they start, so that that's the time of day there's no point in working past. Usually it's sometime between 10 p.m. and midnight. And it says, hey, by midnight, our automatic build is going to start. And once it starts, no amount of commits to Git or no amount of check-ins to Perforce are going to make it into the build till the next day. So there's no point in working past that time. No point in adding bugs past that time. It's one of the few ways we keep developers on track for a long period of time. So we want to have some tools to help us automate these things. We want to have some tools that let us test what we do. We want to have some tools that allow us to create and deploy these things. And we're going to get into how do we do that. The other thing I got on this list is we start building tools. Part of pipelines is figuring out how do you get all of the stuff your creators create into the game. And when we start using game engines, they have some tools and pipelines built into them, but because they're generic game engines, they're also brute force. So when they load in a Maya file or load in an FBX file, they load in everything. We don't always want everything. Or maybe we build some of our tools that add additional information into those Maya files or into those Photoshop files. And our game engine, our Unity, Unreal game engines don't know that information exists, so they just ignore it. They throw it away. Both those cases are cases where we could do some additional work in the authoring tools. And when we do that additional work, we don't want it to get lost. So we need some sort of pipeline to migrate that stuff into our application. So we're going to build some simple Windows Forms UI tools, the kind of tools you would hand off to a game designer, an artist who's non-technical, to be able to let them extract or use certain kinds of tools. Gary out, man. We're also going to take a look at the graphics pipeline. We're not going to look at it from a coding perspective. You're going to do that when you do the shaders class. We are going to look at it from the perspective of what are the basic primitives that your graphics pipeline is doing for you, just so you understand all the terminology and all the things that are going on in the background. When we start talking about that graphics pipeline, it's often a difficult conversation, and you're going to have the same conversation with people creating art. You know, if their character is less than 1 centimeter tall on screen because of where the camera is, and they have 72 bones and articulated fingers, you know instinctively that that feels wrong, but we're going to walk through why is that wrong. Why is that wrong has to do partially with understanding the graphics primitives that we're working with. The other thing I'm going to get into there is we're going to talk a little bit about how the shader pipeline actually works. So we're not going to write any shader code, but we are going to talk about the kind of visual effects you can do. Quite often people get into playing with a particle system and think they're doing visual effects. Visual effects is so much more than just a few particles running on the screen. Usually we use particles to cover up all the other blunders in visual effects that we're doing. So we'll get into all the kind of effects and layers that we're going to put together in our applications. And the final topic I'm going to start to cover is the technical art. Technical art is largely a programming task. And a lot of the reasons we talk about this, because there's a lot of jobs out there for entry-level programmers in configuration management and technical art. Technical artists is helpful if they can do some art, because they can build some of the components that they might need to test and run with. But for the most part, technical art is about augmenting, changing, and improving on the various tools that we use day in, day out. And those tools specifically get lumped into 2 or 3 things. We do use ZBrush, we do use Substance Designer, we do use Houdini, but they're kind of rare. They do very specific tasks. Substance Designer is one of the newer tools that's trying to supplant Photoshop, but at the end of the day, textures need to be authored as images, and those images specifically get manipulated best in Photoshop. That's what most studios use, so that's what we teach people how to use. And we'll show you how to augment Photoshop, how to change and manipulate Photoshop to do things repetitively. We're going to do the same thing with Maya. Maya is kind of the de facto standard modeling tool we use for animation and modeling in all game companies. It's become the standard because most people know it. So if your team uses Maya, then you open up a world of content creators to yourself. If your team uses Blender, you get 3 content creators to choose from. So when you're trying to choose the best talent, you choose the talent that comes from the biggest pool of talent. And that typically is our Maya tools. And we're going to talk a little bit about customizing the developer user interface. And specifically, this is about removing and reducing the amount of clutter in the tools that you're using. And I'm not sure whether you guys have started to see this yet, but in doing your team project, it's probably come across each of you that at some point or another, somebody added something in some art tool that broke most of your game. They changed something, modified something, added an animation to something, added some surface, relocated something, moved something away from the origin that broke your game or made something look stupid or bad. And so when we start talking about UI customization, we start talking about, well, how do we prevent those things from happening? One of the best ways to prevent those things from happening is to simply take things away from people that they're not supposed to have. So it is quite common in industry for us to have a modeling team in our environment group and have that modeling team literally not have the animation tools. So they can't do animations. And their particular version of Maya has those tools removed. Similar, we could take the animators and we could take their modeling tools away. There's no need for them to be modifying meshes if they're not part of the character modeling team. So for them to inadvertently grab portions or polygons out of a character when they think they're selecting a bone and move them, only to find out when they export it and get it in the game and some programmer or tester looks at it, that they've changed or modified that character in a bad way, and then to try and diagnose what went wrong, this is all wasted time. Right? And it goes to another principle that we'll use when we start talking about pipelines extensively. And that's that principle that you want to make all of the tools and systems that you build for getting your content into the game to do as much error detection as possible, as close to the author as possible. So if someone's authoring textures in Substance or in Photoshop, that's where you want to detect texture issues. So what are some of the texture issues you think you would run up? Have you guys ever kind of thought, what could I do wrong with a texture? Right. So when we get into pipelines, we'll start talking about things like, well, how many texture pages do you have for a particular character? Well, it makes no sense to have a texture page that's bigger than the screen resolution. So 1920 by 1080. So there's the first check. Is your texture bigger than 1920 by 1080? And every artist out there will tell you that they want to author 4K textures. And every time they do, I tell them that's fine, but as a rendering programmer, I'm going to take those 4K pixels and I'm going to average them. I'm going to blur them with a gross, hideous, normal, everyday average function. I'm going to take 4 adjacent pixels and I'm going to average their values of red, green, and blue and paste them into a single pixel. And most artists will go, you're going to do what with my art? And I'm going to say, and that's going to take your 4K down to 2K, and my screen isn't even 2K, so I'm going to do it 4 more times and see how blurry your art looks. Right? Now, part of this is also just getting them in shape for doing the right thing. Part of it is because as the programmer, my job is to make the game work and make the artist's art look as best as it possibly can. And one of the ways I can make their art look really good, in this case for textures, for instance, is to not have to manipulate their texture, is to allow them to author their texture in exactly the right scale and format that the game's going to use without changing it. So if I tell them that for this character, I want a 512 by 512 base texture, and I want you to give me one more 512 by 512 texture with the red layer representing bump mapping or normal mapping, and the blue layer representing specular highlights, and the green layer representing, let's say, emissive. All right? And then I'm going to build a shader that uses those different layers to combine them in a different way. What happens when the artist gives me a 512 by 768 texture? Because they will, right? Your pipeline breaks. Your game looks really bad. Something has to happen. You either have to write extra code to manage that error in game, that's slowing your game down every frame, or you have to write some code when the game initializes to check everything and rescale everything, again, slowing your game down, or you just pass it straight through and make it look bad. Right? Now, all of those options are things that Unity and Unreal does. But what we're going to cover in this course is how do you build a tool to make sure the author, the guy in Photoshop, can't export anything other than a 512 by 512. You just simply can't do it. Photoshop won't let you. How do you make Photoshop not let you? Right? So we're going to show you how to make that happen. As we go, you're going to have to choose where to apply some of these things because you can go crazy with them. If you have a 2-year-long project with 250 people on it, you have a whole team of people building these pipeline tools. If you have a 5-person team and 4 months to build something, you're going to have to be selective at picking and choosing what gives you the most value for the least effort. And so we're going to try and give you some guidelines to help you do that. We're going to start with the configuration management part. That's kind of the, how do we build our game? And this comes down to some basic ideas here. Let me clear this dialogue away. There we go. Those basic ideas are really find errors as close to the author as possible. Do things in a repeatable way so that every time you do it the same way, right? Again, think back to your team project. Did everybody have the ability to build their build the exact same way? With audio, with content, right? And if they didn't, what happens when you expand a team 4 or 5 people to 20 people? How much time did you spend going from person to person on your team, particularly non-technical people, and setting up their system, setting up their environment, setting up their source control to do the right things, build the right things in the right order? So the first part of configuration management is about managing a source control system and figuring out how do we build that build. So there is an actual term for this configuration management, or software configuration management, has a formal definition. And that formal definition is all about how do we build our application. We're going to layer some additional things into that, some capabilities. So we're going to want a development build that's built on everybody's local machine. Fortunately, our game engines do this fairly succinctly. You have a little play button at the top of the screen. And if you've got the right source code out on your machine and you push the play button, everybody should get the same output. Plus, you're going to want to have a test build. This is an optimized, completely standalone, does not require the game engine build that you put to the side, and that whenever somebody comes around to try and demo or to try and see the state of your game or your app, you want to be able to run the demo build. It becomes even more important if you're playing a networked game, because all those demo builds are going to need to be the exact same code. Not just what's on my machine and what's on your machine, which might be different because of stuff we've each written. The exact same build. So we want to put those in the exact location because we want to make sure that the network code is deterministic, that it connects the same way, that it runs the exact same way on each different machine, and that they can talk with each other and they're not out of sync with each other. Finally, we're going to want to have a release build, the thing we would show to the public, the thing that has all the debug information stripped out of it, the thing that has all the extraneous files shipped out of it, the thing that's pre-packaged automatically for us to wherever we're going to deploy it. If we're going to build a Steam build, shouldn't we have a folder that has exactly what Steam needs and nothing more? Or if we're going to deploy it to Microsoft, Sony, Apple, Android, same thing. A folder that has exactly what gets deployed to them. All of those companies, when you submit your build to be published, all have guidelines they will test your build against. Sony, Microsoft, Apple will all test your build and will either approve or deny whether they can go to an app store. Steam, Itch, and Google, or the Google Play Store, will all publish your build first and then test it. And if during the testing it fails, they pull it from the App Store. If your Microsoft Xbox build contains Steam logos in it, you'll fail. If your Steam build contains Microsoft logos in it, you'll fail. If your Apple build contains Android logos in it, you fail. If your PlayStation build contains Xbox references in it, you fail. And they all handle certain edge cases differently when it comes to what we call the guidelines. So we want our configuration management or our build process to take care of this. The real world also introduces a couple other interesting phenomena to us. The first one is localization. So we talk about platforms, we talk about localization. Imagine for a second you're on my most favorite game working away. And so the game you're on is FIFA, okay? Now the great part about FIFA is it's been done year after year after year after year, and every time there's a major console switch, they rewrite the whole engine and then keep going. But it makes so much money that they have the right to turn around and say, yeah, you know, I know Unity is a really good thing, but I have a working game and a working engine, so I'm not changing to Unity this year. And then some new console comes out like the PlayStation 5, and you have to decide, are we going to support that or not? And some producer in his wisdom sits down and says, that's FIFA, man, we're going to make more money. How are we going to make more money? More platforms. And so the build matrix starts to grow. Right? This is your final product, what you make your livelihood from. This is $1 billion plus. So it's not just loaded up in Frostbite or loaded up in the game engine and push play. Once you push play and it works, you then have to take it from the development build to a test build. How many test builds you got to make? Well, let's see. We got the Xbox 360, the Xbox One, the PlayStation 3, 4, and now 5, the PC, Switch, Android, iOS. What else do we add in there? That's 9 platforms, all with slightly different art. Do you want to be the person that makes that work? But wait, there's more. How many languages does FIFA go in?
A lot.
16 different languages. So that means on a nightly basis for the QA team, right, you've got to make 160 unique builds. Now, if you're the software configuration management team, and I do emphasize team on that project, you're probably 2 people. And your instructions kind of come at you like this. Your job is to build the game and have one ready for QA the next day. You get to start at 6 p.m. when the rest of the team goes home. Go. Now, when you look at that matrix of builds you have to build, you take a look at, okay, so the compile time's like 5 minutes per build times 10. Plus I got to generate the content. That probably takes 20 to 30 minutes per language, per platform. And you start to find out that this is going to take either a lot of machines or a lot of time. And how do you make sure you do it the exact same way every day? Right? You don't get tired, you don't forget anything. So what do? Normal people, you start making a list. Here's the checklist of all the things we got to make sure. We got to do a get out of the source control system, get a local version. We got to pull from each different branch for each language or each platform into separate folders and start building. Well, that whole process is your configuration management process. And that's what configuration managers do, is they figure out that process. And then hopefully they start to work towards automating it. Now, the automation that you do for FIFA and the automation that you do for Need for Speed and the automation that you do for Grand Theft Auto are all very different things. So it kind of depends on the game you're working on. They all rely on some sort of pipeline, and that's why we call them pipelines, is some way that content gets created and gets run through various different tools to generate game-ready content that gets combined with the appropriate game code. And when it gets combined with those game codes, it gets sliced apart into individual builds representing each product that you're going to deliver at the end of the day. Which means it's always all about that build. And you hear it over and over again. You heard it a lot last term, right? I don't want to look at it unless it's in a build. Right? Well, this is part of the reason why. At the end of the day, we don't ship what's in your development environment. We can't ship your PC to 1 million people. I have to be able to reproduce that in a standalone executable that I can deploy on the target platform anywhere and everywhere. And that's what running through pipelines is all about. It's all about that build. So the first topic we're going to go after is kind of that automation part. And just because I like tying one hand behind your back, we're going to use some of the lowest common denominator, simplest, bare bones tools you possibly can. The things you always have access to, but rarely want to use. And we're going to use some of those tools to try and automate that process. We're going to try and automate and come up with a plan. And the hope I have here is that once you do it for my little sample demo plan, and no, there isn't a ton of actual code to write here, but once we do it for my little demo, you will be able to extrapolate the concepts into working with your term projects. Because in your term project, you're going to run into all of these issues, except you're probably not going to localize it. And you're probably going to pick one platform to go for that's going to be your primary platform. That easiest platform to go for in your term project is the PC. That should be pretty obvious. The most impressive is not always the PC. So depending on how your game design goes over the next 6 weeks or so, you may decide to do a mobile game. You may really go out on a limb and try and do, we haven't got the resources for, but try and do a platform game. Certainly when we get back in person, that's kind of where I would like to go, is to get some console platforms in there for you guys to play with. But we definitely have the mobile platforms. So it's an option you can explore. We want you to take these concepts and be able to implement them all the way through your development cycle. So you get into a proper good mindset with your development team. And that mindset generally for me ends up being, as somebody working on the team, I should be able to come in and focus on, what am I doing today? What am I building or adding to the product without having to worry how I get that thing into the product? It also means the tool should be set up so that nobody requires a programmer or a third-party person to get their content into the game. No artist requires a programmer to get their content in. No designer requires a programmer to get their content in. So if those people need to do some code, you need to build the tools in the game to import their data and to use their data in a format that they can generate themselves. And all of that leads to the number one thing we look for when we're building games, and that is iterations. The more times you can iterate on something, the more variations you can build on it, the better quality your game is going to be. The faster you can iterate on something, the better your game is going to be. So if an artist needs to add a bunch of attributes to every tree they make, and then they need to go talk to an audio guy to attach the audio to those attributes for, say, collision, and then they need to go talk to a programmer to put a collision volume on that asset and then put it into the game, this is going to be a very slow turnaround time if you need to change that tree at all, which is going to make it for a poor quality tree. On the other hand, if you were to build enough tools and pipelines so that an artist could go into Maya, model a tree, add custom data to it with collision types, collision volumes, and sound effects, and live link that tree with your game engine so that as soon as they save it, they turn over to their game engine and it's automatically there. That's a much faster turnaround time. And they will see errors themselves before anyone else sees them on their local build, on their dev build. And they'll be able to go back to Maya and fix it very quickly, save it again, see it again. And you'll get many, many, many more iterations, which means you'll get a much higher quality. And that means that the stuff that people finally put into your source control system to build your final test and release builds will be of a much higher quality with fewer errors. That equals less overtime. That equals less stress. That equals less pain and more fun creating new cool stuff. So all of this relies on configuration management and figuring out a pipeline to build your game. And that's not just I drag an asset into Unity and push play, right? So we're going to explore all the pieces you need to be able to put your own pipelines together. We're going to take a look at how do we do that? How do we modify the authoring tools? How do we write scripts to automate the build part? Eventually, what I'd like to do with that is incorporate the Unity and Unreal Git remote cloud builds, right? The Unity one is brain dead simple, right? The Unreal one, not so much, but they're both doable. And how do I deploy those so that the entire team can get access to them? Then I want to look more in depth at how do we create quote unquote pipelines that allow the content creators to do a better, faster turnaround job. If you have a game designer that's doing missions, do you want them to have to go drag and drop elements in Unity all over the place and script them themselves? Or do you want to build them a mission editor that allows them to go into the current version of the world and place a marker where the mission giver is and to fill out a form that informs on the text that's going to be displayed to them, the quest that's going to be laid out for them, the 3 things to collect, and the reward if the things get brought back to the same mission giver. You're going to have to trade off building that tool versus doing it handcrafted for each thing. And you're going to have to figure out, is that tool best built in Unity, best built as a standalone command line app, best built as a separate Windows app, or do you do something in the web, right? All of these things are viable options. There's no one better or worse. It just depends on how your team and your game is going to evolve. So that's enough of me for a little while. What I'm going to get you guys to do is 2 things. We're going to take about a 20-minute break. But during that break, I want you to do 2 things. So the short thing is, it's time to freshen my coffee. The long thing is this. I want you to go out onto the internet and look for Build Engineer or Software Configuration Manager. I'm giving you a few sites to go look at. These are typically the places people advertise for game jobs. So look for game development, software configuration manager, or build engineer. As a entry-level programmer, these are programmer jobs. And just like a QA job is a great job to get into the games business for a game designer because you see lots of games and get lots of experience, this is one of the best ways to get into a game development team as a programmer. Most game development teams need these people. And if you get through a cycle doing this, you'll know every aspect of how the games go together. And so when that project management team says, hey, who are we going to get to backfill for these 3 people that left? Do I advertise and wait 12 weeks to hire a new recruit? Or do I go grab one of the programmers out of my configuration management team? Right? I go grab one of the programmers out of my configuration management team because they can be working a week later. So go look for these things. I'm going to start up the video back at 10 a.m. Pacific time. Okay? So you got 20 minutes, take a breather, grab a coffee, go do a little search, and then I'm going to ask you guys a little bit about what you find. Okay?
All right.
All right.
Yeah.
Can you tell me what you found?
I'm gonna be honest. I looked in like 5 different websites. I couldn't find a single
Nothing?
job. Nothing
Found
at all.
nothing.
Yeah.
Does software engineer kind of count? Because it's kind of close.
It's like really open.
Yeah, it's really open. That's like everybody.
I know, because I was like,
So
Kind
there's
of.
that.
Maybe it's not the season for that.
Oh, wait.
Let's see what we can find. If you haven't played around and gone here before, you definitely should.
Why Gama Sutra is trying always to put a place in the States for the. If you put Vancouver in there, it's Vancouver, Washington, or something like that.
Yeah.
yeah. Because apparently there's a place in Kentucky named Canada.
I'm sorry, what?
Because I think it's just, I think their API is only linked to like the American Postal Service.
Yeah. Well, until you log in.
Wait, you have to log in. Right? Okay.
Activision, build engineer. Anyone want to go work for Activision? How about East Side Games? Demonware in Vancouver.
I have a question.
Yep.
What does a technical artist do exactly? Because I've heard like stuff over there.
Write tools for artists.
Hmm.
Yeah.
Okay.
Usually that's what they do. So someone says, hey, I want this really cool shader effect that's like a stencil shader, but with a cross hatching effect in it. Can you build me a shader that does that? And give me a tool to allow any artist to apply it to any object.
So he makes the effect and gives like a tool to replicate that?
Yeah.
Oh, cool.
Yeah. Or it might be build me something that I can plug into Unreal that gives me a depth of field effect. Right.
Cool.
You know, kind of a, you know what I mean, depth of field, right? So I can say that the foreground things are all in focus, but the background things are all blurred.
I think so.
Okay.
Yeah, like, yeah.
So some of those are like full screen effects. Some of them are shader effects. Hey, you know what? We've got all these creatures. We'd really like a fur shader. Can we get a technical artist to write us up a fur shader? You guys are all happy with doing that kind of stuff, right?
Yeah. I would. Like, yeah.
Hey, if I got a paycheck at the end of the day for it.
Yeah, and I was talking with some technical artists over there, because I got really interested in that, and they say that the paycheck for technical artists is really high.
Well, it's the same as programmers because they're mostly programmers.
Mm.
Remote opportunities. Let's try the worst site of all.
Oh, Craigslist. Oh, God.
Nope, they don't like that term. Those are the terms you can search for. The upside is every team needs them. The downside is most teams are torn between the way they find these folks. The first thing is, if this is the person that's creating the tools or the scripts or the process by which your final project goes out the door, don't you want that to be a really senior person? And if you want it to be a really senior person, which really senior person wants to do this work? So quite often people hire a junior person to do this work, but then they end up having to learn how everything fits together and how everything works, which makes them far more valuable, but there's far fewer of them. So the typical configuration manager or build engineer on a team knows how all the pipelines on the team work. Characters, props, environments, animations, non-interactive sequences. How does any localized data make it into the game? How does the code get into the game? What platforms do we build for? How to build on each and every platform, followed by how do we automate those things? So some sort of scripting language or tools, plus you're typically a more junior member of the team, so you're going to want to document what you think should happen and then run it through the senior programmers on the team, see if that's in fact the way they view the product being built. Plus you get the pressure where you get the senior guys, the production team, relying on you to find out why a build works or doesn't work. Right? You know, I test something out at 9 o'clock in the morning and be wondering why my build engineer wasn't there because it wasn't working. So I message him and saying, hey, you going to be in the office in the next 5 minutes because the build you built last night doesn't work. And the whole team is not working until you fix it. Right? And there's 120 of us. We're waiting on you. Go ahead.
No, it's like no pressure to this guy.
No, there's no pressure. There are a bunch of strategies for how this works. The daily build is by far the most common, but it's not the only one. One of the strategies for making this work is the continuous build process. One of the teams I worked on did this. So that meant that as soon as it finished, the system finished building one build, it would go back to the source control system and start again. So it took it about 20 minutes to build everything, create a deployed release, and then it would run a few automated tests on it. And when that was done, it would go back to the source control system, do another pull, and start the process again. And it's just an endless loop in the build script. The one thing that team also did, though, was that if the build didn't compile, you would know it pretty quickly, and it would auto-detect it. And as it detected that a build didn't compile, it knew what pull it made from the source control system and who was the last person to submit or commit something in there, right? So it would email the entire team of 150 and say, at 12:53 p.m., Riley committed this change and it broke the build on PlayStation 2. At which point, about 5 minutes later, after that hit the team, a number of senior programmers would stop by Riley's desk and say, hey, you're not thinking of going for lunch right now, are you? Because the last commit you put in broke the build. So how about we, fix that so the team can keep moving? And the idea was you always had a working build. There was never a panic around milestones about how do we make this work, because it was always working. You just grabbed the latest one off the pile. And it also got people into this habit of making sure to test things locally. If you were doing multiple platforms, it was great to write it and make it work on the PC, but you probably were better off testing it on the Xbox, testing it on the PlayStation to make sure that it still worked. Because if it didn't work on one of those platforms, the automated thing was going to catch it pretty fast. And you didn't want to be the person who got the reputation of being the person who broke the build more than anyone else. Now, who on the team do you think would break the build more than anyone? Yep.
Me.
You think you would, Riley? Which role on the team breaks the build the most?
I would put my coins on artists.
You would, that would be your first guess, but it would be wrong.
Programmers?
And specifically, which programmers?
Build engineers.
No, it would be the
Gameplay?
lead programmer.
Oh.
Really?
Yeah. Which programmer do you think touches more code than anyone else?
Oh, that makes sense.
Right? And which programmer is constantly trying to fix other people's problems? The lead programmer. In fact, a lot of the lead programmers have to learn incredible time management skills because they end up working their whole workday solving other people's problems, and their tasks don't get started till 5 o'clock at night when everyone else goes home. So figuring out how to get a lead programmer who's probably one of your best programmers to teach all the other programmers and still do features is a challenge. Having an automated process to help you find these problems on a regular basis makes a lot of sense. Right? We're going to start doing some of this stuff, but I want to break this up a bit. So what we're going to do is talk a little bit about that continuous integration or that continuous build kind of process. So we're going to try and build some sort of automated system for ourselves. And we're going to start simple, just like we would in any real project. You don't build the ultimate build automation system day one. And there is no single build automation system that fits all projects and products. So you kind of have to custom craft these for every project you build, which is why you typically want to start very small and very lightweight so that the build system can be shown to not have any errors itself before you start relying on it to build your game. As your game grows, so your build system should grow. One of the things we want to do with this build system is to make sure that we automate anything where human interaction is involved with creating that final project so that we remove any repetition mistakes. You know how I was saying earlier, you probably want to put together a checklist of all the things you have to do to build a final build, to build an executable. You know, when Chris and Derek say, hey, show me your build, show me an executable, don't show it to me in engine. That executable has to be built by someone somewhere. And I'm sure you've all tried to do it manually. But there's a bunch of steps you have to go through to do it. What we want to do is automate those steps so that you never forget one. The other reason for this is that as your project winds towards the end, people will end up working a little bit more time. And that little bit more time, hopefully, is on making quality features and making things work. You don't want them to have to worry about, now that I made this new feature work and it's getting really close to alpha, how do I get it into the game without breaking everything else? So you want to get into a system where for everybody on your team, it's a matter of, I make it work on my local dev system, I put it into the source control system, and I go home because the automatic overnight build will pick it up and work. If you can do that, if you can get that to happen automatically, then you create two things. You create a great culture where people can focus on doing their work and not how does their work show up in the build for tomorrow. You can create a place where people feel safe to experiment with things because they know if it works on their machine and they put it in the source control properly, it'll make it into the final product. And you build a place where people can know that they can only work to a certain period of time, because once the automatic thing starts, it's really hard to stop and restart manually. You can also change the frequency of it. So if you're not on a continuous build cycle, you might decide to build one build every day and test it in the morning and see what things need to be addressed that day on top of the features of the day, what things are broken. As you get towards a milestone, you might accelerate that to 2 builds a day, one at lunchtime, one overnight. So you get this kind of continuous progress report on where you're at. And then if you get sophisticated with it, you could decide to, say, capture the output. You know, when you run the compiler, you get that huge list of warnings and errors that comes out the back end, right? And usually it's so big that everybody just ignores it. But most teams really should get rid of all warnings and errors. Well, what if you were to capture that output, run it through a program you wrote to filter out the things you want and auto email them to the appropriate people on the team? What if everybody got 3 things that were automatically injected into Pivotal as your issue tracking system based on the overnight build? Highest priority, just add them directly into the issue tracking system. So you're looking for ways to automate things that will make people more productive, give them more time to work on actual features and fix problems rather than figure out how do my fixes make it into the final build. See, people get tired and lazy and complacent, and so inevitably what will happen is somebody will forget to do some step that they were supposed to do to make stuff land in the game. And when they forget that step, it turns out that that will create a broken build of kinds. So when people are relying on this, you kind of want something that's reproducible. You also want a situation where anybody on the team can grab or use the build. You don't want it so that just one programmer is the person who builds the build, right? Because then that programmer gets sick one day. Or if you're an external developer and you get paid based on delivering a milestone build, and the guy who builds the milestone build either breaks it, his hard drive crashes, or he gets sick that day, right? Does the whole company go bankrupt because you didn't collect a milestone payment because you couldn't spit out a milestone build? Or do you have a process and a system that allows an automated system to build that build independent of any of the developers on the team? Well, I know where I lean on that. So we want to automate all of those things. So we start with this kind of notion of a software configuration manager, and we build out an idea of the kind of things they're responsible for. In a small team, usually what it is the lead programmer or the more senior programmer will work out all of these steps and how the team is going to do this, maintain the automation part through the course of the project, and be responsible as one of their tasks to keep the automated build running and live at any point so that every other member of the team can always check out the latest build. Now, how far you go with automation and how far you go with auto documentation, if you will, is entirely up to you. A lot of people get into doing this kind of stuff where you're literally cobbling together things that were never meant to work together and trying to spit out some sort of information. If you were to take those compile logs, plus some information that were gathered by, say, you wrote a tool that would process every piece of art that was generated for a game and do some analysis on it. Let's say part of your team's rules were all of our texture art are going to be powers of 2 squared. That way we can scale them using bit shifts instead of multiplications, and they're orders of magnitude faster. So let's say we decide to do that. Can we write a tool that walks through every JPEG or every PNG or every TGA that we generate and verifies whether or not they're a power of 2 squared? Probably. So if we could do that, we could generate a report. And if we generate a report, we could either auto email it to somebody, or we could format that report and put it as a text file somewhere. Or maybe we could format that report as HTML and put it on a web server somewhere. And that way, anybody who wanted to see the status of your game could go through and see what it looks like or see what the status output is. Maybe we could do some more automated things. What would happen if, say, I were building a level and I wanted to check out not just performance, but progress on the level every day, but it was deep into the game and I wasn't necessarily going to get to see it? Could I, in fact, go into, say, Unity and place, as part of my initial white boxing of a level, say, 6 cameras in that level and never move those cameras again? But part of the automated build could be to go through the game, compile it, build it, and then run it with a command line option to step to each one of those cameras and take a screenshot with the profiler on so I could see what the frame rate was where that camera was looking. And then I could dump those pictures, for instance, into a folder every day. I could go to a website and see that set of photos for any given level. I could then flip day over day and see the progress of my game. I could also do stuff like that and then take a look at the frame rate report. And if all of a sudden one day I added a new tree and my frame rate went from 60 frames per second to 10 frames per second, how much time would I waste trying to figure out why my frame rate went completely south one day? As opposed to waiting till the end of the milestone and then finding out that the game's super slow and then having to do all the detective work to find out why is your game so slow. So a little bit of pre-thought and a little bit of automation can help a tremendous amount in terms of building our final project. And that's that kind of idea where content creators are going to be working in an environment where putting things into the source control system is going to build confidence with them that an automated build will build it correctly. And once that confidence exists, they will be able to go through and check that their stuff is in the game properly. It's going to show up the next time the art director comes around to look at it. We're also going to do some automated testing so that we can verify simple things straight away, and we can shortcut the amount of detective work that we have to do. We then feed those reports back into our development process, whether it's a pseudo manual process or an auto email process or a generation of content that we inject via a RESTful API into something like Pivotal or Jira or whatever we're using to tracking issues. We can integrate those things nicely and cleanly. We also have to manage releases. That's part of our build engineers' work, right? So all of this automatic daily build is really there for people to review the game. But one of the things we're going to want to do with this is kind of manage our disaster process. We're going to want to figure out, what do we do if one of the key members of the team lose their hard drive? How do we make sure we don't lose everything? And the bigger the team and the more money invested, the more important this is. One of the least liked parts of doing that build engineering job is once your project ships, you're going to have to archive it in some way. And especially if your project has an ongoing maintenance kind of capability, if you have to operate it live and you have to work with different web technologies to make sure that happens, we're going to want to put those archives to test. We're going to want to make sure we can reproduce any version of our game again. Now, the tools for doing this kind of vary as well. Some of the standard automation tools involve most of the scripting environments that we're used to seeing. So shell scripting, the command interpreter under Windows. We're going to take a look at some of these dependency-based tools, and those are things that say, if this is newer, then go ahead and rebuild X. If this is newer, go rebuild that. And that's part of a performance idea of if you have 30,000 files in your project, but only 4 of them changed, you need to recompile and rebuild everything. And we'll do some smart work with that. We're going to take a look at task runners and automated test tools at a very high level to know what exists and what's out there, and try and integrate some of these task runners into some of the work we do. Anything that you can do repetitively, you can schedule to do on a regular schedule. We're going to have to deal also with building our own internal tools and integration points into other components. So for instance, if you build a tool that checks every texture, as I mentioned, then you probably need to take a look before you build the game and see if the source files for that tool have changed. If they've changed, you need to rebuild the tool and then rerun the tool, the new tool, on all of the old content. So that ties those dependency-based automated task runners with your own internal tools. If you need to deploy something to every member of the team, you probably need to build it and publish it somewhere and notify them if they have to do anything to upgrade themselves. Those parts are all part of that configuration engineer. We also have to build any sort of variations of the game if we have multiple consoles or multiple languages. If we have pre-rendered scenes, which fewer and fewer of us are doing, we need to manage our render farms. Sometimes these build systems, especially if you think of that FIFA example, you don't just do that on one computer. You effectively try and line up a computer per platform so that your generation can happen largely in parallel. And then you have to make sure that you have the right amount of network space and disk and bandwidth to make sure that your build happens quickly. We also got to be able to test on all our target platform devices. So we probably want to also auto deploy to some places. It's very common for Xbox-centric worlds to auto deploy an Xbox build directly to a person's Xbox. So here's kind of the process we go through. We kind of look at the problem we have to solve. How do we build our final version of our game? We figure out what is the workflow. In other words, what data gets created by whom and has to go through what tools to get into the game, where it needs to be compiled together, assets and code, to figure out what our final product looks like. And then how often do we need to build that? What kind of requirements do we have for putting those things together? We then want to figure out what analytics we want to compile out of that. We want to figure out where we're going to publish our results. Could just be a simple text file in the beginning. And as you go, you might decide that people aren't checking the text file, so you're going to email it to them, or you're going to put it on a website somewhere. And then how are you going to communicate up and out? What are the key new interesting features you're going to do? Are you going to pop a message to Discord every time an auto build happens? Or are you going to pop a message to Discord for every milestone build? Or are you going to have a separate build channel that people can pay attention to if they're interested? The way we do this is we work out what we call a workflow diagram. And these workflow diagrams are charts of how your build operates. We kind of figure out all of the sources for information and all the places they're going. We figure out all the translations we're going to do from one kind of data to another. And then we figure out where the key things we're going to build land. And those key components we need to support by diagramming what we're going to do. We're going to try and keep it simple, right? And we're going to use some simple diagramming capabilities to put these together. Now, we're going to do this next class because I've hit my hour and a half I want to work with today. So we're going to take another 15-minute break. Next class, I'm going to talk less, and you guys are going to build these workflow diagrams for a fake project first, and then for your final project second. These workflow diagrams should fit on a page. We're going to need a diagramming tool. We'll walk through how we do this. We keep it really simple, lightweight. This is not going to be something that's going to be hours and hours of homework, okay? So we'll get into that next time. We'll diagram a process, and then we'll set to building some automation tools that match our workflow diagram. The use of Unreal and Unity will make some of this really, really simple and straightforward when it comes to importing assets. Those things have pipelines in Unreal and Unity that we can take advantage of. All right. Okay, I'm going to take a 15-minute break again. We're going to start at 10:45, and we're going to switch gears entirely and talk about the cloud. In particular, we're going to start into how do we get the game we built last term to actually operate against a cloud-based server. So we're going to start prepping ourselves for that. All right? Okay, I'm going to shut it off. We'll come back at 10:45.